Hi, everyone. Thanks for coming. I appreciate you making the long trek up both escalators. So this talk is about how does bundler work anyway. This is a question that I ask myself on a regular basis. So I figured I'd write it down, and then I wouldn't forget, maybe, I hope. Unfortunately, I'm sorry in advance, telling you the answer to this question is going to require a brief history of the entirety of dependency management in Ruby. No big deal, though. Before we dive in, I'm Andre Arko, as you've heard. I'm indirect on pretty much all the internet things, and that's my tiny internet picture, which might be more recognizable than my actual face at this point. My day job is being a Ruby and Rails and team training architecture stuff person consultant through Cloud City Development, mostly in San Francisco. I wrote a book. I co-authored the 3rd edition of the Ruby Way. It's pretty cool. I learned Ruby from the 1st edition of the Ruby Way, so it was a great feeling to be like, oh, I made that now. Pretty cool. I work on Bundler. You may have heard of that. I hope you've heard of that. And my life-consuming side project is Ruby Together, which you heard about yesterday from Pat. If you didn't hear about it yesterday from Pat, we take money from companies and people who use Ruby, and we take that money and we pay developers to spend time working on Bundler and Ruby Gems and the rubygems.org web app. Pretty great. We like having infrastructure that works. At least I like having infrastructure that works. I hope you all do too. So, if you're interested, I have lots of Ruby Together stickers. Come see me after the talk. I will hook you up. All right. So, sharing Ruby code. Using Ruby code written by other developers is super, super easy, right? You add it to your gem file, you bundle install it, you start using it, done. That was it. Pretty great. So that's cool, but what just happened? That is what the rest of the talk is about. So based on, I'm guessing that if you, as your eyes glazed over while bundle install printed things out, you probably concluded that something got downloaded, and you probably concluded that something got installed. You did type bundle install after all. But what got downloaded, what got installed, where did it go, why those things, how do you use someone else's code just by adding the name of it to your gem file? So I will explain all of those things, hopefully soon, but small diversion first. I kind of have to take you back in time to the beginning of dependencies in Ruby, because the reason why things are how they are today is really just a result of how things were before, which is a result of how things were before. So we're going to start at the beginning. I'm going to start with require, a Ruby method that you've probably also heard of. And then I'll talk about setup.rb, a Ruby thing that you probably haven't heard of. And then we'll go from setup.rb to Ruby Gems and then to Bundler, and why exactly it is that dependency management for a single project is different than having gems that exist. So, start with require. So the require method has been around since at least 1997, which is the oldest Ruby code that we have in version control that we can still access. Unfortunately, we don't anywhere on the internet have a copy of the CVS repo anymore, but we do still have the SVN repo, and it goes back to 97. And even though require is that old, you can still break it down into slightly smaller concepts, right? Using code from another file is practically the same as copying and pasting that code directly into the file that you're using. So you can implement like a naive require function with literally one line of code. This is really straightforward. You tell it a file name, it reads the file off of disk, and then it takes the string that has the contents of the file and passes it to eval, and it runs the code. You may have noticed there are some small problems with this implementation, among others. Among other problems with this implementation, you can tell it the same file name twice, and it will run the code twice. That is less than ideal. The second require will like reinitialize values, redefine classes, overwrite methods. It's not great. So let's hypothesize how you might fix this. What if, hypothetically, you were to create a global array, and whenever you eval that file, you just put the file name in the global array, and if you've ever evaled that file before, you skip it. So this is pretty good, hypothetically speaking. Turns out in reality, there's a global variable that's an array, and it's named loaded features, and it contains a list of all the files that Ruby has ever required. And in fact, Ruby uses that to track whether it should require something or not. Now there's a new problem. This only works with absolute paths. And maybe it's less than ideal for you to have to pass the absolute path, including your username, to every file that you want to use in your program. So the easiest way to allow requires that aren't absolute is to just treat every file name as if it's relative to the directory, like the current working directory where you started the program. That's easy, but it doesn't work well if you need to be able to require from multiple directories. So let's hypothesize about how you might fix this problem. What if you made a global variable and you put a list of directories in it, and then when you run require, you look for the file that's being required in every directory listed in that global variable? Well, it works pretty well, and there is a global variable named loadPath, and Ruby does, in fact, look in that list of directories one at a time for anything that you require. Whatever's at the front of loadPath is the first place that Ruby will look when you say require blah. So I guess needless to say, this is not the actual implementation that the Ruby interpreter uses, but this is the functionality provided by Ruby. Ultimately, load paths are pretty cool. You can find Ruby libraries spread across many directories. So at this point, I'm going to leave the combined implementation as an exercise to the reader because I couldn't fit all of the code onto one slide. But now we have a require function that can hold the Ruby standard library in that list by default. And now you can say like, oh, I want to load net HTTP. And it says, oh, well, this standard library directory is on the load path by default. I found it. Here you go, all set. So this is actually pretty great. You can use code from multiple directories. So the next problem that arises once you've solved those problems is what do you do if you want to get code from someone else somewhere else on the internet? Well, I guess you could make a directory, you could put that code in it, you could then like manually add that directory to the load path every single time you start a Ruby interpreter and want to use it to do something. This got really tedious. Someone had a bright idea of saying, hey, we should just make a default place where you can add stuff and Ruby will always keep that place on the load path. It's called Site Ruby. Almost no one uses it anymore, but it's still there because yay, backwards compatibility. And once we had Site Ruby, someone said, oh, hey, we could just write a script to like automate installing new libraries, right? And that is setup.rb. Setup.rb was written sometime between, like somewhere around the year 2000. I'm not sure exactly, but amazingly, this library, setup.rb, is still on the internet in a Subversion repository hosted by its author, Andre Arko, and he has the best website, i.loveruby.net. And you can even download setup.rb to this day and try to run it, although you might not want to since no one has touched it since 2005. But setup.rb solved a real existing problem, which was I have downloaded a tarball with Ruby code that I want to use, and now I need to put it in the right places so that my Ruby will be able to find it when I call require. And so setup.rb was really like strongly inspired by the Unix tradition of make files and running configure, make install. And so as you can see, there's kind of like an echo of that trilogy of commands provided by setup.rb. And once setup.rb became the dominant way to install shared code, which didn't actually take very long because it made it completely automatic, this was the steps that you would follow, right? You would browse the Ruby application archive, which is where all the cool libraries lived in 2003 or 4 or whatever. You would find a library, you would click a link, it would take you to the homepage of the person who had written that library because the RAA didn't actually host the tarballs. And then you would download a tarball, and then you would decompress the tarball, and then you would cd into that directory, and then you would run ruby setup.rb all, and then it would print out a bunch of stuff, and then you would have the library. It was great. You could just require it, and it would work. It was a big improvement, right? You didn't have to figure out where to put it. You didn't have to manually put it there yourself, and require just worked. As you may have noticed, possibly, there are some small problems with this strategy. Among others, there are no versioning. There are no versioning. There's no versioning of libraries at all, and there's no way to uninstall things because you're putting everything into the site Ruby directory and you have no idea which files belong to which libraries. So if it gets updated, how do you find out? Well, you have to go back to the RAA and you have to remember the version number that you installed. And then how do you update it? Well, you have to repeat the process of going to the homepage, downloading the tarball, CDing, decompressing it, CDing in, running setup.rb all. And then you have to hope that the new version has the exact same file names as the old version so that it gets overwritten exactly correctly. Because if they don't share file names, too bad. I used Ruby a little bit during this period, and I regularly just ran rmrf site Ruby so that I could reinstall the newest versions of things and they would actually work. It was terrible. Also, this entire process maybe sounds a little bit tedious. That is an accurate representation of how it was. Yeah, so at this point, people said, wow, this is really tedious. What if you could maybe just give the name of a package and it would find it, download it, decompress it, install it? That would be amazing. So in 2003, the first version of RubyGems came out, and it fixed all of these problems. There was a single command. You just ran gem install, and you got the library with that name. And so this was amazing, very seriously. Like, in comparison, oh my God, it was so good. But RubyGems came with another really, really, really significant feature, which is the idea of versions. And so you could install more than one version of the same library and tell RubyGems which version you wanted and get that version rather than whatever the newest was. And so if you don't tell RubyGems something specific, it'll give you the newest one that you have installed already. So that looks like this. You call the gem method and you tell it the name and version that you want, and then RubyGems does some magic inside the require method, and then when you require rack, you get exactly rack 1.0. Mostly what happens is that RubyGems rewrites the load path to only contain the directory where it installed the rack 1.0 gem and nothing else. This was part of the revolution of RubyGems. It installed every single gem. It actually installed every single version of every single gem into a completely different directory so that manipulating the load path would determine what libraries you were able to load using require. RubyGems also adds a really, really clever trick that basically no one knows about because Bundler makes it irrelevant, but I still think it's cool. If you call a command provided by a gem, you can pass the version number that you want inside underscores as the first argument, and RubyGems will make sure that it runs that version of the gem and then pass the remaining arguments to the gem itself. Honestly, today, nobody cares, but I was real jazzed to find out that this existed once. So, good news. Gem install has made it super, super easy to install gems. There's been an explosion of gems. There are a lot of gems now. There's about 100,000 gems, and there's about 1 million versions of those gems. Today it's actually probably closer to about 110,000 and 1.2 million versions. So gems go real fast. I guess I should update these slides weekly or monthly or something. So this was so great, and Rails was so great at making people productive that they started writing a lot of things using Ruby, and that's when we discovered the next problem. What if you have two applications and they have different gem version requirements, but you need to run them both on the same Ruby? So you have an app, you're like, oh, I want to run your app. They say, okay, well, you just have to run gem install Rails and then you can run my app. And I say, great, gem install Rails. And Ruby Gems is like, cool. And now my app that I built on a slightly older version of Rails is loading the wrong version of Rails because I ran gem install Rails. So, unfortunately, when I became a full-time Ruby startup Rails developer in roughly 2006, the state of the art was, here is your new work laptop. We're going to be super excited if you boot the Rails app on your new work laptop in less than 7 days. I was really, really focused, and also I was, the office was out of town, so I had nothing else to do. And I got it up and running in only 3 days, and all of my coworkers were like, wow, that's so impressive. And so recognizing that this problem existed, Rails tried to solve it. So this is like 2007, 2008, something like that. Rails said, hey, well, you could just tell us what gem names and versions you need, and then we'll make sure that you get the right versions. And there was this tiny problem with that, which was that to run this code, you needed to load the Rails gem to find out what version of Rails you needed to run the code to, yeah, okay, I think you get the point. So into this world in approximately 2008-ish, this is like the normal situation of development using Ruby. This is a personal story from roughly 2008, where I spent 3 days debugging an exception that only happened on one production server and not any of the other 4 production servers, and didn't happen on any developer laptops. But one of those machines had literally version 1.1.4 of some gem because we built that box, I think 3 days later than the other boxes. It's like, oh, we need to increase our capacity. Okay, it's real easy. There was a backwards compatibility breaking change in 1.1.4. And that meant that one of our 4 app servers didn't actually work whenever you tried to do one specific thing on the website. It was the worst. There were other cool problems. The version conflicts, like we were talking about. You install Rails, you run one app, then you switch to another app, and now it's the wrong version of Rails. Less than ideal. And finally, there was a cool activation errors problem that a lot of people said, well, how common could that be really? And then a new version of Rails came out, and everyone suddenly had this problem. It was very cool in the sense that no one realized that this was going to happen. And the web server that ran Rails, which at the time was thin, was very up to date and was like, yes, I depend on features that are in Rack 1.1, so I need Rack 1.1. And then the newest version of Rails said, oh, well, I'm conservative and I'm not sure if Rack 1.1 is going to work for me, so I demand Rack 1.0 point something. And then at that point, Ruby Gems would say, your gems don't work together, sorry, too bad. And this was effectively an unsolvable problem. So the moral of this story was Ruby Gems at the time did what we called runtime dependency resolution. Do these gems work together now that as I pull them in? And what we decided we needed was install time dependency resolution, where you check to make sure that all of the gems that you're about to install work together once in advance, and then it's fine, they'll all just load. So how do we do this? Well, this is the ultimate problem that Bundler exists to solve. Checking to make sure that all of your gems work together at the time that you install them, and then writing down the set of gems that we have checked and that we know all work together and loading those all the time. Effectively, before Bundler existed, this was a problem that developers solved by hand. If I change this version to that, does it work now? No. If I change this version to that, does it work now? No. So it turns out computers are better than humans at that problem, at that. Let's check every single possible solution. Computers are also much faster than humans at that. And so Bundler is now able to do this. So Bundler does this thing, dependency graph resolution. Here's a graph of dependencies. And this is an example of a well-known hard problem in computer science and mathematical theory. It's called NP-complete, which means, in theory, it is possible to construct a set of gems such that Bundler could never find a list of versions that all work together before the universe ends. We do a lot of tricks to try and find a solution before the universe ends. You're welcome. So we use a lot of shortcuts and heuristics, and most gem files actually now resolve within a few seconds. There were years, honestly, where there were some gem files that took somewhere between 5 and 20 minutes, and that was less than ideal. So Bundler produces this Gemfile.lock, which is just a list of the exact versions, and we know that all of those versions will work together. So here's how bundle install works. It reads the gem file and the lock if there is one. It asks Ruby gems for a list of all those gems, finds the gems, writes down the versions we need, installs them. Hooray! Bundle exec does the same thing, but at the time that you run your program, and says, hey, do I have all the gems I need? Great, put those in the load path, go. Pro tip, this is pretty cool. You can use the bundle bin stubs command to create a command that you can run that will only ever have the correct version of the gem for your application. So this bin rspec that lives inside your Rails app will always load the version of rspec that your gem file says it should, even if you have 25 versions of rspec installed on your machine. I find this very helpful while working on lots of Rails apps at the same time. That wasn't the end. We're still working on Bundler. We're still making it a lot better. Over the last few years, we've added a bunch of stuff, we've fixed a bunch of stuff, we've made it a lot faster. I would love to have your help if you're interested in contributing to Bundler. Poke me on Twitter, send me an email. I will set you up with the new contributor welcome pack and get you pulled into the Slack where everyone hangs out and talks about how horrible Bundler is. Or, if you're too busy, Ruby Together, as previously mentioned, exists to pay people to make sure that this stuff continues to happen. That's it. Thanks, everyone.